All right, we're learning about geometry, points, lines, and planes. So, our first figure we're going to talk about is a point. So what's the point? Well, we're about to find out. So I guess the point is, it's an exact location in space. So for instance, we're right here on the Earth. So that would represent an exact location in space. All right, our next figure we want to talk about is a line. So a line is an infinite number of points extended forever in two opposite directions. So here, line AB or BA, or we could also use a cursive letter like letter L to represent this line, but they go forever in the A direction and forever in the B direction. And there's an infinite number of points. There's a point right there, right there, right there, an infinite number. All right. Next figure we need to learn about is a line segment, and a line segment is part of a line. So here our line segment is CD, and if we were looking at that other example, line segment AB would make up part of that line. And it doesn't matter the order that we say it, so we could say CD or segment DC. They mean the same thing. And it's part of a line that has two endpoints, so it doesn't go forever in either direction. It stops here and it stops there. All right, our next term, or our next figure, is a ray. And no, it's not your Uncle Ray. And no, it's not the sun's rays. A ray is part of a line. All right, so this ray is part of a line, but it only has one endpoint, and it goes forever in one direction. So when we name it, we always need to think, this starts at W, and it goes forever in the X direction. So to write that, I would put WX with an arrow over the X, showing that it's going forever in the X direction. It's not going to be XW, because that would show that it's going forever in the W direction. And that would only be true if the ray was drawn from this point with an arrow going through the W like that. So it's not that way. That's why I put that in red, because that's a common mistake. You can't just flip those around and it's okay. All right, and our last figure is a plane. And how did I know you were thinking of that plane? See, I'm thinking more of this plane. A plane is just a flat surface. So think of a tabletop. All right, so this plane shows a flat surface, and it contains many lines. So there could be a line here, a line there, there. There could be a line going through the plane, up and down on the plane. But it needs 3 points to name it. So here I named it with P, Q, R, and S. You can use as many points as you want, but at least 3. Or you can just have one letter that names the entire plane. So this could also be called plane W. But if you're using points, you need to use 3 points. And actually, one of them needs to be on a different line. So you can't just pick 3 points on the same line. All right, if you need to pause the video, go ahead and do that, because we're going to move on to an example. All right, example 1. All right, go ahead and copy down that figure for example 1. And your first question is going to be to name 4 points. All right, see if you can find the 4 points that are on our figure. All right, if you said M, N, O, and P, you are correct. It doesn't need to be any particular order. Those are our 4 points. All right, second question. Can you name 4 different segments? That means representing different line segments. All right, think about that. What are 4 different segments there? All right, now let's talk about them. You could have segment MN. Segment NM represents the same one, so let's go on to a different one. How about segment NO? Or we could go all the way there, so M all the way to O. And I see one more there. We could go from N to P. So I'm seeing 4 different segments. Let's write those down. We have MN, segment MN, segment NO. We said we could go all the way from M to O, Mo, or NP, standing for no problem. All right, next question. Write 6 other names for line MN. All right, jot that question down. I want you guys to be thinking of those 6 other names for line MN. All right, and let's see what we came up with. Now this isn't saying other lines for MN, it's just 6 different ways to write MN. So we could do MN, NM, NO, ON, MO, and OM, and we can also use this cursive letter W. All right, let's write those out. So we had NM, MO, OM, NO. That's what I tell my daughter a lot of times. ON, and we could also use the cursive letter W. All right, your last question. Can you name 5 different Rays? Wait, I thought I told you couldn't use your Uncle Ray. Well, since Ray's here, he can help us answer this question. What do you think, Ray?
Well, you could start at N and go in the O direction, or start at M and go in the O direction. I didn't learn all this math when I was your age. We could start at the N and maybe walk in the P direction.
All right, I think Ray's left a couple out. Let's see if we can help him out. All right, well, Ray, you said N and then go in the P direction. That's right. And we could go in the MN would work. MO would work. NM would work. And OM would work. And then how about ON would also work? How many is that, Ray? Oh, we got 6? Oh, we found more than we were supposed to. Good job. No, the sun's rays don't count as 7. Nice try. Oh, wait. Ray just pointed something out. MN and Ray MO represent the same ray. So those aren't really unique, are they? Because we need 5 different rays. Not 5 different names, but 5 different rays. All right. Thank you, Ray. And thank you, Ray. So MN and then NO. Or we could do ON, NM, or NP. So there were only 5. Now if it said 5 different names, we could have reused them, like we tried to. But Ray helped us out, didn't you, Ray? So sometimes your uncles know what they're talking about. All right. Go ahead and pause the video if you need more time. Oh, it's getting hot. All right, two terms we need to know. Parallel lines, just like if you're driving on the road, parallel lines are going to be two lines in the same plane that never intersect. So think about your road. You have parallel lines anytime you are on a road, don't you? As long as they're marked. So they never intersect, and they're in the same plane. They're on a flat surface. Now there's another type of lines. We have intersecting lines, but let's talk about skew lines. You know what? You have no clue about skew? Well, don't skew up as you write this down. Hold on a second. So skew lines are lines that lie in different planes, and they never intersect, and they aren't parallel. All right, now this is going to be something that I think you learn much more visually. So as soon as you copy down those two definitions, we're going to draw a box. So I'm going to start by drawing just a little rectangle here. And I'm going to draw another rectangle up above that rectangle. It's going to be the same size and shape. Okay, I like that one a little better. And after you've drawn your two rectangles that are, and these look a little more like rhombuses that I've drawn, but you can just draw two rectangles. Connect each of their vertices. So that's the vertex here and the vertex there I'm connecting. That one goes with this vertex. I'm going to use a dotted line because that's behind where we can't see. We can see this line, so I'm going to draw that solid line there. We can see this one, so that's a solid line. And there's actually one more thing, because see, this is our base right here. So if that's my base or my bottom part of that box, then I should really be erasing a little bit here and making those dotted lines in the background. And I think that looks a little bit better for our picture. There you go. So your dotted lines are what's behind that you can't see. All right, I'm just going to label these now, and you can do that with me. We have A is this point, B is this vertex, C, G, F, E, and then this one's going to be H, and I'm missing one. It's going to be that bottom one that we can't see, the D. All right, so I have all my points labeled on my rectangular prism or my box. And now I'm going to just ask you a couple questions. So, first question. All right, so write this question down. BC is, or line segment BC is parallel to what two lines? And I can name lines or line segments here actually. I'm going to call that line BC because that's bugging me since I used the term line there. Not a big deal, but I think it was. So line BC is parallel to what two lines? All right, well here's BC. So what's parallel to BC? Well, this means the same plane. So this is that top plane. GH is parallel to it on the top plane, but BC is also part of another plane. That's right, the side plane over here, that left side. So that's the top part of the left side. That would be the bottom part of the left side. So it's also AD is parallel to BC. All right, let's write those down. Okay, so GH is parallel to BC. They're on the same plane. They never intersect. And then AD is parallel to BC. All right, not too bad for parallel. Let's try one with skew now. Okay, your question is, HE is skewed to what 5 lines? HE is skewed to which 5 lines? All right. Well, here's HE. We're looking for lines that are in different planes and that are never going to intersect and they're not parallel. So GF is parallel to HE, so that can't work. BA is parallel to HE, so that can't work. So those are off limits. Why don't you pause the video and see if you can't find those 5 and check them with me. Whoops, don't be lazy. Let's pause it and try it on your own. And now for the solution. All right, so HE, represented right here by the red line, is skewed to CD, which would be back here to right there, because they're on different planes and they're not parallel and don't intersect. Also to FD, which is also in a different plane, and they're not parallel and they don't intersect. And then BC, they're on a different plane, they don't intersect. And then AD, they're on a different plane, they don't intersect. And finally, CG. Up here, they're on the top plane, and this one's on the front or the side plane. So those are on different planes as well. So there are 5 of them. Did you find them? If not, go ahead and rewind and look at that again. I hope you didn't skew up.